With this video, we begin to review a series of problems that I like to call applications of the fundamental theorem of calculus. They are the types of problems that show up on an AP test, both for AB and BC, and they're typically calculator-based problems. They are meant to give you a feel for how calculus fits into the real world in a number of scenarios. So with this problem, we have the temperature outside of a house during a 24-hour period given by the function capital F of t is 80 minus 10 times cosine quantity pi t over 12 for t between 0 and 24, where capital F of t is measured in degrees Fahrenheit and t is measured in hours. So the first thing that we want to do is to sketch the graph of f on the grid below. And to do this, we're going to bring in the graphing calculator. Now, do you need a graphing calculator? You really don't. If you plug in t equals 0, you're going to get 80 minus 10 times cosine of 0 being 1, so you're going to get 80 minus 10, which is 70. If you're to plug in t equals 6, you're going to get pi over 2, cosine pi over 2, which is 0, and so you're going to get 10 times 0, which is 0, 80 minus 0 is 80, and so that's also pretty straightforward. When you plug in 12, you're going to get cosine of pi, which is negative 1, and negative 10 times negative 1 is positive 10, so you get 80 plus 10, which is 90. Going to 18, you get cosine 3 pi over 2, which is also 0, and so you're going to be back at 80 for that one. And at 24, you're going to have cosine of 2 pi, which is 1, and so you have 80 minus 10, which is 70. So even though it looks pretty complicated, it actually is a very simple function to graph. Now I'm just going to draw in the smooth curve, which this would be. Now, just by guessing, you may not get the concavity right, but you can certainly go to your calculator now to confirm those results. So we open up the calculator, we go to y equals, and we type in the function 80 minus 10 times the cosine of pi x instead of t divided by 12, and because of the order of operations, we don't need parentheses around the numerator or denominator here. Next thing I'm going to do is set up my window, and I'll set it up to match exactly what's given here. We have x going from 0 to 24 by 6. The y's are going from 60 to 100 by 10. And that should do it. Once we have that all set, we should be able to go over and graph. And we do want to make sure that we're in radian mode, which we are, and we can see the graph looks something like that. So this is a calculator problem. It's okay to use the calculator, but I just wanted to show that you can get a lot of those points there without even doing that. Alright, so that's part A. We'll put the calculator away. Part B says find the average temperature to the nearest degree Fahrenheit between t equals 6 and t equals 14. Now there are two important concepts that we're going to work with a lot, and you need to make sure you understand the distinction between them carefully. And one of them is the average rate of change. The average rate of change is just the slope of the secant line connecting two points. But the key word in there is rate of change. In this case, we're asked to find the average temperature. Now, it doesn't have to say average rate of temperature. If temperature were in fact a rate by itself, we wouldn't need that extra, the redundancy of the word rate in there. But temperature is not a rate. Temperature is a measurement of something. It's not a rate of change. So the second quantity that we will work with often that's similar to this, or appears to be similar to this, is the average value of a function. So before we go into that, I just want to show what would the average rate of change of temperature be from time t equals 6 to time t equals 14. Well, that would be f of 14 minus f of 6 over 14 minus 6. But that's not what we're working with here. The average value of the function comes from the idea of the mean value theorem for integrals, which says that an integral from the area under the curve of a function f of x from a to b, or the area under an irregular shaped curve from a to b, is equal to a rectangle that has the same base, b minus a, and has a height given by some point on the curve within that interval. And that value, f of c, is the average value of the function. And if we were to solve for f of c by dividing both sides by 1 over b minus a, or multiplying by 1 over b minus a rather, we would get 1 over b minus a times the integral from a to b of f of x dx. And this is the quantity that we want to work with in this particular problem. And we'll continue this in the next video.